for the minimum x -1, maximum x. So this is x min, and this is x max, and then y min as -10 and y max as +10. And from the graph, we're gonna use the graph to find the one-sided limit as listed as A, B, C, and D. Okay. All right. Before we look at the graph together, did anyone finish finding the limit values for A, B, C, and D? If you finished, okay, let's see. What do you get in part A? Limit as x approaches 0 from the left of the function. Would that be positive infinity or negative infinity? You can type either plus or minus sign from the graph that you got from your calculator. Jeff got plus sign, yes. How about the rest of the class? Okay, we got plus sign or positive infinity. We do not have to put plus sign when you write the answer, but when I asked, because I wanted you guys to tell me whether the direction is positive sign or negative sign. Okay, yes, we get positive infinity. Very good. Thank you, Jeff. Thank you, Leah. Thank you, Austin. So how about part B? As x approaches 0 positive from the right side, the function goes which direction? Up or down? Plus sign or minus sign? Minus sign, yes, negative infinity. Okay, thank you. How about at 1? As x approaches 1 negative. Now coming from the left side of 1, the function goes up or down? Negative, or go all the way down, negative infinity. And then the last one, as x approaches 1 from the right. So the right graph approaches positive infinity or negative infinity. Plus sign or minus sign for the right-sided limit as x approaches 1. What do you think? Plus sign, yes, go to positive direction, positive infinity. And I'm gonna share the graph real quick. So this one, if you do not have the calculator, you could have done it by hand. And later in this section, we're gonna analyze from looking at the function. We analyze, that means we do not use the calculator. Okay, this case is just like put the concept together. Since our function is 1 over x squared minus x. In the case that you don't have the calculator in your handy or next to you, you can see the denominator can be factored as x multiplied by x minus 1, correct? X or x times x minus 1. That means x cannot be 0, x cannot be 1. We know these two numbers, we cannot include it in the domain of the function, correct? And as you see in the graph, it will give you the vertical asymptotes at x equals 0 and x equals 1. On the left side of 0, whatever the value that you enter into the denominator on the left side, the value of x is going to be negative. So this is negative sign. And then 0 minus or lower than 0 is already negative inside. Minus 1, it still gives you the negative quantity. So negative times negative, you would get the product of these two factors as plus sign. We know the quantity going to be very, very small because the number approaches 0. It's small already before you multiply or subtract it by 1. Okay, so that means the whole fraction here will return positive inside, but it's going to be in the form of 1 divided by very, very small number. That means the function value will be very, very large. Think about when you divide, the smaller denominator gives you the greater product. The product quantity. The positive quotient. Sorry, I used the wrong term. So like 1 divided by 2, comparing to 1 divided by 10, the larger denominator gives you the smaller quotient. That's similar way, same idea. You divide by very, very small number, so then the quotient becomes very, very large. Okay, and so from doing by hand, at least you get two numbers, x equals 0 and x equals 1 as a vertical asymptote. But the way that we gonna find out whether it goes all the way up or all the way down, that we're gonna see in the later part of the package. Okay, question for this problem. Everything good so far? Yeah. Okay, let's move on. So this one, number 3, sketch a possible graph of a function f together with the vertical asymptotes, satisfying all of the following conditions. This time we do it backwards. Instead of giving you the graph, identify the limit. This time gives you information and you have to put pieces together to sketch the graph that corresponding to this provided conditions. Okay, we have f at 1 equals 0, f at 3 is undefined, limit, this is two-sided limit, as you see no superscript plus or minus sign, the two-sided limit as x approaches 3 of this function equals 1, and the one-sided limit at 0, the limit value approaches negative infinity, that means the graph going down. Okay, the limit of the fx as x approaches to two-sided limit because no superscript plus minus sign. So both sides of the two, let's see. So this is, I'm gonna write it. If this is a 0, if this is 0, the graph going down, okay, on the right side of the 0, going down. So for this, if this is a number 2, the graph, both direction, it goes all the way up to positive infinity. And the last one, the limit as it approaches 4 negative, for 4, coming from the left side, the graph go all the way up. So we kind of analyze it piece by piece, and then we put them all together. So the lower 3 terms there, they are limit. And how about the limit as x approaches 3? At the point 3, the limit approaches 1, not positive or negative infinity. So that means it doesn't matter on the left side or on the right side, this value of the function approaching to the value 1. So the value 1, so y equals, not y equals 1, but y approaches 1 as x approaches 3 from the left side and from the right side. Okay. For f at 1 equals 0, think about f as a y. This one you can see as y at 1 equals 0, or if x equals 1, the y value equals 0. What does it tell you if the order pair that has y equals 0? Think about the xy plane. Where is the point 1, 0? Could you tell whether it's on the x-axis or the y-axis? Hi, Jonas. Could you tell where is the order pair 1, 0 located on the xy plane, the x-axis or the y-axis? You can type in the chat if you on the x-axis. Yeah, that's right. That is located on the x-axis. And if the graph passing the x-axis, what is it called? It's called the x-intercept, right? The x-intercept. Okay, and then the middle piece here, f at 3 is undefined. Undefined means you cannot identify the value on the graph as x equals 3. One of the cases that we looked over when we did 2.2, remember the 3 cases when we look at the graph, either the graph connected or the graph not connected with the jump somewhere to identify the function value, or the graph is not connected. That is the whole appears on the graph. So this time f at 3 is undefined. So that means on the left, on the right, we don't know what's going on, but at the point x equals 3, no function value is defined. So going to be the whole. Okay, going to be the whole. Now we're going to put all 6 different situations here all together. And look at x that involving in this situation. We have x equals 1. So we make a list for the x value. X equals 1, x equals 3, x equals 3 there, x equals 0, x equals 2, and x equals 4. So when you sketch the graph, make sure you cover these x values, one basically from 0 to 4. So your graph would have the scale including 0, 1, 2, 3, and 4. So guess it doesn't mean have to be perfect, okay? As long as we hit all the information provided. And now the function value at 1, x equals 1 is 0, okay? So this is the value 0. So let me clear up this a little bit. So first one, f at 1 equals 0. So that's the order pair that I asked you earlier. Okay, so this one is the order pair 1, 0. This one, check, we use it. Next one, f at 3 is undefined. Well, not much that we can do. We know that we cannot put the dot or connect the graph at x equals 3, but with the condition limit as x approaches 3 equals 1. Okay, x approaches 3, the function value approaches 1. Okay, if the 1, this is the y-axis, this is y equals 1. At the point 3, coming from the left, coming from the right, the function value approaches 1. At the same time, f at 3 is not defined. That means it's the whole appear, and then the graph coming from the left, from the right, we don't know yet what direction it's going to be. So coming, approaching to this number or approaching to this whole, okay? So we use this and use this. And now the last three limits. Limit as x approaches 0, positive, approaches negative infinity, approaches 2 both sides, the function approaches positive infinity. Limit as x approaches 4 from the left equals equals positive infinity. The last 3 gonna give you the vertical asymptote, because the graph either go all the way up or go all the way down. So what are those vertical asymptote? X equals 0. So this one is, I use VA as vertical asymptote. X equals 2, vertical asymptote. X equals 4, vertical asymptote. All right. So we're gonna draw the vertical lines passing through the point x equals 0, x equals 2, x equals 4. Okay. And next, we're gonna put the direction of the curve. As x approaches 0 positive, that means from the right side of 0, the graph go all the way down. Go all the way down here. This go down, approaching 0, or approaching negative infinity. And then on the left side and the right side of the 2, the graph approaching positive infinity. Okay. At 4 from the left. Okay, from the left, the graph approaches positive infinity. Positive infinity. Now we're gonna put all together. Let me see if I can use different number. It's getting messy with the same color here. Okay. So now we're gonna connect the curve all together. Like from the right side of the 0, since the low end here approaching negative infinity, if you keep going, gonna pass x-intercept, and then keep going, approaches positive infinity. And then over to the right side of the 2, approaching positive infinity. But when it gets close to 3, the limit value approaching the value 1. Jump, because at this point, the function is undefined. And over to the right, it keeps going and approaching 4 from the left, approaching positive infinity as x approaches 4 from the left. So this is one of the sketch curve that satisfy the information provided.